Hey guys, welcome to the Intro to Agoric workshop. Thanks for coming. I just want to say up front, this whole workshop is done as a GitHub repo that's publicly available. Whenever at your convenience, when you're walking out, coming in, wherever, taking a break, there is a QR code on the door, which you can use. Otherwise, if you're willing to sort of do this manually, you can go to GitHub and go to RBF Labs, github.com/RBF Labs. And there's a gateway repo which you can clone right away. So talking about concepts in Agoric and typing this out, but I wouldn't worry about you guys copying like what I'm writing on the board, because it's a lot of effort. But whenever you want to refer to the code, the exercise spaces inside the repo, but there's also the solution right next to it. So at any time you can go and have a look at what the solution looks like, right? So it's no stress. Let's have some fun. Let's dive into Agoric. I think it's an interesting piece of tech. So I was lucky, was already up on the conference and explained a lot of the things that are the basis for sort of this talk. So let me just do this very quickly. What are the blockchains that we're used to if you were deployed on any blockchains? It's today you get a blockchain sort of base layer. You get the platform which does the consensus for you and it provides for you a virtual machine. And you compile your code straight onto that virtual machine. If we're talking Windows, imagine everything you driver. Everything you write as a device driver, it sits right on top of the hardware and can do whatever it wants. So this is sort of like where we are mostly today. So that's one part of this. As a result, a developer who writes the smart contract has absolutely full control over what happens inside the smart contract. And there is practically no user protection, right? I mean, in Uniswap, you can say, technically, the UI could show you, oh, I'll accept your whatever atom back, but then when you say, yeah, I want to, shows up, hey, do you want to send your USDT into the contract? When you say yes, that you out, there is no guarantee that you're getting anything back, right? There's a lot of effort gone into battle testing this, so you should get your stuff back. But my point is, that only depends on what the Uniswap guys have done, but the platform itself under that is not guaranteeing you that any of that will happen, right? So what that happens is the developer has a lot of responsibility. And on the other hand, and the user doesn't really have any protection from the platform. It means developers have to be super careful. Any bugs whatsoever, they're liable for. Any caveats, they have to take care of all that. On the user side, user doesn't really get any protection on the blockchain today. And what I want to show you is on Agoric, they do actually for many types of transactions. The one thing that often happens, I don't know if anybody here has ever done that, but it's easy to send funds to the wrong address. So some blockchains have checksums for the addresses, so you can't exactly make whatever typos, but there's actually no guarantee there's anything else on the other side of the address. Once you send money somewhere and this address doesn't have any associated private keys, like that's it, the money's gone. A popular address is 00000. So there's a lot of ETH there. It's a burn address, so some of that ETH is rightfully there. It's gotten to the place as it should be. But many times people have sent ETH there unwittingly. And it happens so often. There are scams based off of this. So I screenshotted one. I used to work in Avast, which is an anti-malware, antivirus company. So always interested in scams. You can see somebody. What happens if I send transaction to the wrong Ethereum address and somebody here is willing to help, and they're referring people to a website called ncybernet.com. Very favorite tactic of scammers. It's got a comma instead of a dot. If it's a dot, it's picked up by URL scanners and it can be scanned, right? But if it's a comma, it doesn't look like URL address to an automated scanner. So standard trick in the book. And everybody's of course interested, how can I get my money back? And the answer usually is you can't. We could look at this. There's an Etherscan link. By the way, this presentation is also linked to in the GitHub repo. So if you open up the GitHub repo, you can straight click through this and look at this on your own computer. You can look at this link. We could look at the transactions that go here, right? But I don't want to spend time on this. So one thing is like users aren't really protected against making mistakes, and it's just hardcore addresses, right? There's hex strings which you have to retype and work with if you want to send somebody money. There are also so as I said, the developers have to be really, really careful not to introduce bugs. Here are a couple of examples. And by the way, I'm not knocking any of these blockchains, right? They were the first players, first runners. They've built up an enormous amount of effort has gone into the innovation that were provided today. But now the question is, can we do things differently, right? So that's the starting point with which I'm giving this presentation. I don't know if any of you have looked at the Agoric difficulties. So what happened is they had a smart contract up and was basically an NFT auction. You could go buy an NFT, many people could bid. And the way this is done on Ethereum is everybody bids, one person wins, but they all have to lock up their funds. So the smart contract knows they're convinced they're actually putting their funds in. And then everybody who didn't get the NFT has to get their funds out. If you have a bug in the refund code, the money is staying inside the contract. That's what happened, for example, with Agoric. So there's a lot of people hurting. Somebody bought the NFT, but everybody else is sort of out of their money. It's 33 million locked in. That's a lot of money. There was something called infinite spending approval on Ethereum earlier. I think that doesn't exist there anymore. But you could approve, you could give rights to a smart contract to ask your wallet for money. So there's parity, there's compound, there's all sorts of other examples, right? So there is this problem exists. What's the Agoric idea? How to help with this? Write contracts in a restricted version of JavaScript that's hardened, and that's a technical means to help the language be sort of more conducive to producing an object that says, okay, this object now is describing a value of, let's say, $150, and make sure nobody else can change this object in transit. So it's a lot of freezing and reducing the mutability. But what's more important, what I feel is really, really key here, is Agoric doesn't actually just provide a VM, it provides a set of services like Zoe and ERTP that your contract gets to interact with, and they do a lot of the heavy lifting for you. And that's actually the point of this talk. I want to explain why. So you've seen in the previous slides why these things exist, and I want to go through these and show you what sort of services they provide and how you can work them. And there are two big things I want to focus on. One is electronic rights transfer protocol. So this is a whole infrastructure about that works with that allows you to define and mint sort of payments, tokens of different kinds and work with them. And then there's another big subsystem that's called Zoe. And Zoe is a system that enforces what's called offer safety, which we'll go into when you write this stuff. But the idea is, as a user, you can say, I would like to give this contract A, and in return, I want B. You can say that when you are starting your interaction. And Zoe, when you interact with the smart contract, Zoe is there in the middle, and she escrows the assets. And if for whatever reason the smart contract wants to keep your A but doesn't want to give you the B in return, Zoe will not let this transaction go through. And this is regardless of why. Is it malicious? Is there a bug? Is there a mistake? It doesn't matter. So if you structure a transaction as an offer that's a quid pro quo, and the contract doesn't give you the quo, the deal's off, right? And you'll get your stuff back. The other part of Agoric is object capability. Why is this? So this is an idea where if you have access to an object, you can use it. If you don't, you can't. This works on Agoric because by default everything's private. So on Ethereum, everything's public. If I deploy a contract, you can go through the blockchain and look at every contract, right? So the Agoric's not built like that. So as a creator of a contract, I can deploy it and I get back some objects, and I can list some objects publicly, but I can keep some objects for myself. And that's important. So in Ethereum, you'll see all this like function calls where is the message sender the creator of the contract? No. Is it the person who is in the governance list over here? Yes. So you have to do a lot of access control inside all of the functions. Here, what you do is you take this reference and you give it to person A, to person B, and that's it. So how is this accomplished? This was also being discussed today. I guess all of you have seen the slide, so just very quickly, there's a Cosmos Tendermint base that gives Agoric the benefit of IBC, which is really great, interact with other Cosmos zones. Then on top of this, there's an Agoric VM, which is a hardened virtual machine that provides a JavaScript runtime environment. And Agoric, as Dean said today, is the team that's been helped create the VM. On top of that sits ERTP, Electronic Rights Transfer Protocol, which is a unified way to talk about value. And on top of that sits Zoe, and on top of that is where your contracts are. So you're using all these services there, right? So how does this work? Just very high-level concepts. Interaction with a Agoric smart contract involves invitations, and this is really the keys are sort of not having addresses. I can go to a public version of the contract and say, can you invite me to interact with you. And then if it's a public invitation, you get an invitation. And then you can redeem that invitation by sending an offer. Say, I want to use this invitation, and this is the offer, and I want to give this whole thing to the smart contract. The offer contains what we give and what we want. These are actual keywords in the structures we'll see. And then we attach, if there are any payments we're making, we attach any of those payments to the offer, and this whole thing gets sent, and that's where Zoe picks it up. So smart contract starts running, and then when it's finally done, there's an offer result. We can get the offer result back and examine what happened. So this whole thing looks complicated if you're used to Ethereum, where it's a call function, RPC call, function comes back. But the point of this whole infrastructure is it protects the user and the developer, and we'll see exactly how. So that was high-level concepts, and if you're all ready, then we can just start coding. So I've got my Visual Studio here. As I said in the beginning, don't really worry about, clone this GitHub repo, and at your leisure you can type in some code or whatnot, but I'll be coding about stuff that I talk about. So the first contract is called contract 0, and it focuses exclusively on the ERTP layer. We're going to try to build these concepts one from the base layer that we talked about. So the repository, why don't you take a shot of the QR code on the other side of the road? It's github.com/RBF labs. And there's like 3 repos that are public, and one of them is this one, RBF Labs. So ERTP. So the new concepts that we'll be talking about in Agoric are issuers, brands, amounts, payments, and purses, which is sort of the infrastructure to work with value and amounts. And there's test-driven contract development. So on this very contract, I'd like to show you a good way to work and actually develop your contracts, write your contracts, because Agoric has this nice thing, which is a test framework built in that you can use. And you can use this to experiment with Agoric and see what works and what doesn't. That's actually really powerful and very nice. So contract 0, what I like to do is I'm going to write a terminal. I'm going to run a terminal here. And I'm going to go to contract 0. And then I'm going to say npx ava and start testing my contract. Right? So there's always a source code for contract, and then there's your test code for the contract. I'll start up the watcher. And here's the thing, in the very first part, I'm not even going to have a contract. This contract is a basic stub. It doesn't really do anything. It just shows you what the contract form sort of is. I won't spend any time on this now, because what's interesting is what we're going to do with the tests here. So I can still use the testing framework even though I'm not developing any contract. I'm going to use it to work with these mints and issuers, etc., to show you what's going on. So let's look at how we can talk about amounts. In Ethereum, you have stuff called safe math, so you have to be very careful when you're changing amounts, adding things, subtracting things, dividing things. There's fixed point math, and it's maybe not super easy to work with that. You have to be very careful. So here there's a unified way to work with amounts. So what do we do if we want to define some sort of token that we want to work with? Well, we need to create a kit. Make issuer kit. So I'll make an issuer kit, and it's going to be for Moolah. And the kind of the kit is going to be asset kind NAT. So NAT is the type of asset that's fungible. So you can have 20 Moolah, 10 Moolah, you can add them together, get 30 Moolah, right? This is fungible. So and I'll just go ahead and import this from Agoric ERTP. As promised, it's the ERTP layer. Now this kit gives me a issuer, a brand, and a mint. Moolah kit. So the issuer is the object that understands this currency. It's the keeper of the type, and it can verify whether some payments belongs to the currency and can tell us various things. The brand is actually something that denotes the name. It's this type. The brand is a unique object that identifies Moolah inside the system. The mint is the only object that's allowed to create value, right? So I can mint a payment, so I can mint 20 Moolah only using this mint. Anybody that doesn't have this mint, they're not making any payments. So let's look at amounts. So how do I define 20 Moolah? Well, amounts in the financial system, it's a good idea to have them coupled with a type. So the way to work with amounts inside Agoric is called amount math, and I'm going to make Right away, the code intelligence suggests I need a brand and a value. So the brand is the brand I got from the Moola kit, and the value is going to be 20. So I append this n because this is supposed to be a big number. It's not, just to make sure there are no overflows, no difficulties with numeric precision. So this is an amount of 20 moolah. Then I'm going to ask the mint to mint me a payment of 20 moolahs. So I'm going to ask the mint. And the mint is super simple. You can see here, you can ask the mint which issuer, who's your issuer, and then you can mint a payment. That's it. So it's really a simple object. And I need to give it an amount that I just defined in the previous step, right? I'm going to just fix the typo over here. So what we can do in this very first test, going to make it really simple, we can test whether this payment actually contains the right amount. So for this, we'll have to use a test called deep equal. So this is part of the testing framework AVA. So I get a T object, which I can use to verify things inside the test. And actual expected. So actual is, I'm going to ask the issuer to tell me the amount of the payment that's contained in payment moolah, and I'm going to see if this is actually moolah 20. And first I'm going to make the test fail, by the way. I'll write this. Now you guys can see that, oh yeah, give me 1 second. The import needs to be here up top. So code intelligence helps me by by importing automatically, but it imports at the top, and you need to have the test import needs to be up top. So I fixed that. Now what I'm getting is a difference. Like one thing is a promise and the other thing is actually an object. So what needs to be here is an await. So writing this in tests can tip you off that you're supposed to be awaiting something and you're not, right? So I'm going to save this and rerun the test again. I'm still getting a failed test, and here's the difference. I'm actually the get amount of is returning to me an amount that's 20, and it tells me it's of the moolah brand. So this tells me already, I'm pretty sure that if I write this, my test is going to start to pass, right? All tests passed. So the only thing I wanted to show here is if I want to talk about some tokens that are fungible, I need an issuer kit. That gives me a few objects that I can work with, and the most important is I can define amounts. The amounts always have like a numerical value, but they also have the type. So the brand. What are you talking? 20 of what? $20, 20 moolah. So this always goes together. And amount math gives us other functions that we'll use later. Okay, so let's move to the next test. I'll just save this so the test fails. So now we have a failing test. Let's talk about purses. So I'll just copy this over so I don't have to type the whole thing again. But what's the new thing I'm going to do? So I minted a payment of 20 moolah, and now I want to deposit it. In the Agoric system, a purse is part of your wallet, or it's an object that can hold value, but only of one type. So the purse that I define as a purse for moolah, I can't hold USDT, right? So, and this is all again a part of the construction that sort of separates these concerns. So I'm going to say this is where the issuer comes in very handy. Issuer make empty purse. So now I have an empty purse that I can deposit the payment into. So I'm going to say purse deposit the payment. And what I'd like to do now is check inside my test whether the purse actually has the worth in it, the value in it. So I'm going to say T deep equal, and I'm going to say purse, how much do you have in you, and is this the same as the amount that the payment corresponds to, and the purse was empty before I deposited the payment, so that's what we should have, right? So I'm going to make the test fail again first, and then I'm going to make it work. So. Right, so I'm using, again, all tests pass. So I'm using the test framework to actually tell me what I'm doing right and what I'm doing wrong. So this is really important because Agoric is being developed very fast. And to be honest, this tutorial is probably going to be out of date in 3 months, in 5 months or something. So the thing that I'd like you to take away from here, I'm going to repeat this several times, is that you can use this testing framework to test at any time what your code is doing and if it's doing the right thing. And you can confront that with the docs, right? So this is actually tremendously useful. Amounts can be added. So let's now define a few amounts. So I'm going to use the very same issuer, the very same brand, very same mint. And I'm going to define a couple of objects here just to show you how amount math works. So I'm going to say make brand, same brand and amount 30. And I'm going to make third amount, which is 50. So now you can tell me what I'm going to check. and 50n. We're going to see if we add those first two amounts, if that comes out as the mul of 50. So I'm going to say t deep equal amount math. And here, look at this. We get a lot of useful functions. Is greater than or equal, is the amount empty, add. I'm going to use add. I'm going to add mul of 30, mul of 20, and compare this to mul of 50. Right. So obviously tests work. If I change this amount over here, obviously tests fail, right? So it's actually testing whether I'm getting the right 50. Now, the question is, how does amount math work for things that model non-fungible assets, like think of this like NFTs? So what happens, right? It's very easy here to think about how add works, but how about we create an issuer? I'm going to call this my awesomes. It's a new NFT collection. Not financial advice, but if you want to buy it, it'll make me happy. I'm gonna float this on the test, and it's totally legit. Make issuer kit. I'm gonna say awesomes, and it's an asset kind. And if I want to talk about different non-fungible things that are not interchangeable, it's the asset kind is set. So now again, it's the same object though. It's a kit. So I can get an issuer out, a brand out, a mint out. And that's my awesomes, and I can rename it awesomes kit, right? I can rename it to my awesomes kit. Now, how do I define values? So it's an asset kind of set. So every individual value has to be a set. So I'm going to make an NFT A, and I'm going to use amount math to make a type, the NFT which has this brand. And now here is my awesomes 1, the very first awesomes NFT. Make another one, and amount math make brand awesomes 2. And what do you think an amount would look like that has, if I add these two NFTs? What's that going to look like? Any guesses? Yeah, it's going to be an array, and I'll just contain these two objects. I'm going to introduce a typo here just so my tests failed initially. And I'm going to say, okay, let's see if I add these two NFTs. So there's an NFT workshop after this, and they're doing composable NFTs. So they need to be able to combine these values. NFT combined, right? So this test should fail now, because why? So that's the first failure. So we talked about a hardened virtual machine in JavaScript, and part of that, and right now what you have to do, you have to assure that the objects that you want used to describe amounts are what's called hardened. So the VM that runs Agoric provides a function called harden. The harden function actually chops off functionality from this array. So this array has a string in it, and if it's a standard JavaScript object, I can go into that array, I can swap the string out, I can change it, I can do whatever I want with it. Harden takes away some of those capabilities to make sure the object can be tampered with later. So what I was told here is you can't pass non-frozen objects like awesome. So the harden function performs a freeze. It freezes the object so it can't be manipulated with. This is again, use tests for this, because it'll tell you where your mistake is, that you haven't used harden. Like you get a hint here. You likely won't get a hint if you're deploying on contractor, or not necessarily now. So now that we've hardened things, what happens now? Can't pass non-frozen objects. Of course, I haven't hardened everything. So here, very nicely, tests warn me, or the system warns me. Now that I've hardened everything, the only reason the test is failing because I have a typo here. So I'm going to make those amounts the same. And here we go, tests pass, right? So you get out of the box. So if you haven't developed on any blockchain, this doesn't seem strange to you, but on other blockchains, you don't really get frameworks that allow you to abstractly talk about amounts and how to combine things together. So these are all libraries or frameworks that you have to develop outside. Here, you're given this out of the box in Agoric. So this contract, these tests allowed me to explain how ERTP works, how you can mint payments, how you can move them to purses, how you can talk about amounts. Are there any questions at this point? Did you guys want to ask? Yes?
That's my understanding. Some blockchains in mint, you mint all of them, or some dApps, you mint everything at once. Some you mint based on your action. So if you mint all at once, you just run this
So that's a great question. Thank you. And the big question is who owns the mint after you make it, right? So in the next smart contract, which is like a facet contract, the mint is going to be owned by smart contract. It's going to be in it, and we're not going to export it. Nobody else but functions inside the smart contract closures can access it. So in this scenario, what you could do is, and the facet actually mints to anybody who asks. So in this scenario, the mint can be used by smart contract to mint new payments and move them out of the contract to the user that can then do whatever they want with them. You could pre-mint a specific amount, so you could open a purse in your smart contract, you mint the initial amount, and then you throw away the mint. If I show this open source code to somebody, I can prove to them that the mint's lost. So you'll spawn the contract. In the beginning, in the start function, what we're going to do is we're going to run the mint, and then we just set the mint to null, and lose the mint, right? And then you're not using it anywhere. You have to throw away the issuer kit as well. Just be careful. But it's possible to signal that this mint has been used, and now we're not going to make it accessible. None of the functions use the mint at all. Once the contract's deployed, that's it. Make sense? Perfect. Any other questions? Because we're moving one layer up, right? Anything you want to ask about mounts? This is the best place, because then we have to talk about smart contracts as well. So all good? Perfect. Okay, so now I can move. And by the way, one last thing before we move out. This is a bonus problem. Agoric is actually interested in rewarding anybody who shows some effort in studying this by themselves. So at the end of the workshop, I have some QR codes here. If you photograph them and solve or try to solve any of the bonus problems, you can take a shot of the QR code, send them a screenshot, and if you pass KYC, if you're willing to show your paperwork, they'll send you $100 because you've solved or tried to solve some of these bonus problems. So this is one of them, right? Try to see what happens if you try to add two identical NFTs. So let's say you mint two amounts that are the same NFT and try to add it. I'm not going to do it here, but if you guys want to try, regardless of whether you solve or don't, you can then screenshot this to Agoric. Okay, so let's move on to the next smart contract, to the next exercise. So that's contract number one. And by the way, as I promised, there's always a contract solution. So the test contract is empty inside the GitHub repo, but you have the contract solution and it's commented. So at any point, you can go back and refer to this and use this as a starting point for whatever you guys need. Okay, so smart contract and test contract. So in this exercise, we will develop our first smart contract, and it's going to be a facet contract. So it's going to contain a mint, and anybody who asks, it will mint them some moolah currency. I'm very interested where these names come from, but moolah is used all over the documentation. I thought it was a safe name to use that nobody's using as an actual currency, but I don't know what the story is with these names. So when we are testing an actual contract inside a unit test, what happens is we have to make a fake environment and deploy the contract into it, and then we can test it out. So there's a standard set of boilerplate that we use for this, and it's here for your convenience in the comments, right? So instead of the pass, I'm going to deploy this, and of course I have to import all of this functionality. And there we go. Import all these functions. I'm getting code intelligence support, so I don't have to do any of these manually. And I'm going to move the test up here. Let's see. And I'm going to start npx, ava, and test my contract. Right? Can't find one. Yes. So code intelligence is incorrect here. I have to fix this. Anyway, the solutions contain the correct import. So I already have a test failure here, and the test failure is you didn't test anything, right? So what's going on in these functions? The computation inside the Agoric VM runs in VATs, which are discrete units of computation, which are isolated from each other. So what we need to do is make a fake VAT into which we can deploy our contract. Then we want to get access to the Zoe service, which is inside the VAT. We will bundle the source code of our contract. So this actually points to the contract we've got over here. And we bundle it. And then we install the bundle using the Zoe service, and we get back an installation. So this is now the code's been uploaded. That also happens in deploy scripts. when you're working with the AG Solo processor, we're working with testnets. So you get back an installation handle that says, look, this is a reference to the code that's already been uploaded to the process, and you can now work with it. So the first thing that we're going to do is we're going to run a test that asks, hey, is this installation actually the installation of the code that we wrote? So I'm just going to say t is, so this is another way, this is another testing primitive, and I'm going to say await e hello installation. So I'm going to ask the installation, give me the bundle that you were installed with, and I'm going to see if that's my hello bundle. Right? So super simple test. Let's see what happens. 5 tests pass, meaning my test passes. So all I did now, this is doing nothing useful. What I did was I instantiated, I moved the contract code to the chain, and then I simply asked the installation, hey, tell me what code is deployed here, and is it my code? So that's all I did. Right? So let's move to the next test, which is start to be a little more interesting. And we're going to start using this sort of test-driven development style. So we've got this installation. I copied this. We know already it works from the last time. And now we are going to we're going to actually start the code inside the process. We're going to get back an object that we can then use to call functions. And the first function that we want to implement is actually super simple. It's a function called say hi, and it's going to return to us the string hi. So we have to install a contract. We've done that. Now we're going to instantiate the contract, right? So called const instance is await e Zoe start instance. So start instance is how he asks Zoe to take the code that's been uploaded and start it for us. So hello installation. So this is now a running instance, and the instance is actually an object which I can deconstruct. So I'm going to say, and let me creator facet. So I'm going to say, give me the creator facet. So facet is a term you may be familiar with. I think it goes back to a long time, to when Dean was talking about when they were working on smart contracts. I don't think it's very popular in any language today, but the idea of a facet is simply think of it as if you have an object that's got a large interface. Let's say it's got 50 functions. I model the term facet is I can take 10 of these functions, build a new object that only provides access to these, and this is like one aspect of the original interface. It's just like one facet. And then I can create another one. I'll pick another 5 functions, and that's a new facet. So we use the term facet to describe different parts that are then transferred to different parties. I'll give you the creator facet so you can mint, and I'll give you the public facet so you can buy, right? So this allows us to sort of separate out this functionality, and goes back to this is very interrelated with this idea of object capabilities. So I'm going to deconstruct the instance, get me my creator facet. And inside the creator facet, there's actually a say hi function, or there's going to be a say hi function. And then I'm going to call it. I'm going to say t is say hi, and it has to be, I'm going to ask for we're going to write the function to just return the string hi. So this function doesn't do anything useful, right? But the idea is to show you what does it mean to start an instance, what do you get back, and how can you work with this, right? So we've got this. The instance actually can be deconstructed in creator facet, and the is a say hi function. So what am I saying by this? The person who deployed the contract is the only one that gets to access to the creator facet. This is just for me. The creator facet is where I place functions that I want me, the creator, to be able to use. So then I just grab this function, because it's an object, it's a JavaScript object, and grab this function and just call it, right? So this test fails now, obviously, because the contract doesn't actually contain this function. So here's how we're going to code it. Start slow and simple. So the creator, I've already prepared the creator facet here. Let's go through this. The start function has to be declared for any contract that you want to deploy. The system is going to look for a start function and run it. The start function gets a Zoe contract facet. Now, I just explained what facets are. So this is the part of Zoe that the contract needs. So it's a facet of Zoe that the contract is typically uses. And I can use this ZCF to make new mints for myself, and I can use a whole lot of other services, but we're not going to use it right now. What I'm more interested in is this creator facet. And a lot of these things are just simple JavaScript objects which are transferred by convention to different locations. So it's actually some of the reality may be simpler than you think when I'm talking about all of this infrastructure. So I'll just define a say hi key here, and it's going to be a function that returns the string. I think we said it has to return hi, right? So this gets wrapped in a creator facet as a normal object. The object is hardened. The start function is also hardened, and then it's exported, right? So if I save this now, and I rerun the tests, all my tests pass. What happened? So now I actually wrote into the smart contract this function say hi. I put it into the creator facet. It's all being moved through to my test code after I deploy it. After I start the instance, I get the instance back. I can open up the instance to get the creator facet. I open up the creator facet to get the say hi function, and I can use it, right? Now this is a really simple example because this say hi function, I can call it locally, but stuff gets hairier a little bit when we build more functionality. So the next thing that I want to explain is how to use invitations. So right now there are no invitations involved in this. I deploy the contract, I get a function back, I can call it. But the way you really want to interact with smart contracts is using invitations. And when a user has an invitation or another smart contract has an invitation, you can use the invitation to talk to the contract. And that's really what gives you this sort of address safe. You can't send something, if you need an invitation to send something somewhere, you can't exactly send something to an empty address because there's nothing giving you the invite. There first needs to be something that gives you an invitation so you already know that thing exists, right? Let's do this, right? So again, I need to copy all of this stuff, and I'm going to copy it including the instance over here. So I'm just going to put this together. So I've got my instance, and I'll say, okay, give me the creator facet. I'll deconstruct it from the instance. Could have copied that as well, but I just love typing when I'm talking. So, and then there will be another function which says make hello invitation, and that's part of the creator facet again. And I can, so how would I like to do this? I want to make myself an invitation by calling this function. And then I would like to redeem this invitation by making a contract. And this is where our first interaction with Zoe is, right? So I'm going to have to say seat is await Zoe dot offer. I'm going to use up the invitation. And my proposal is empty now. I'm not actually providing any value, or I don't want anything back. We're just showing how to use invitations, right? And this is the flow. I get an invitation, I send an offer to Zoe, and then I get a seat at the table. So this seat, it's really like, think of it like a chair. So when you're interacting with a smart contract in your head, think about the smart contract being a table, and there are chairs around this. If it's a swap contract, then one person sits on one side of the table, another person sits on the other side of the table. One of them is a seller, one of them is a buyer. They have seats inside the contract. They actually have objects called seats. And those seats can then transfer value into the contract or extract it out. And they are your handle to what your role is inside the smart contract. So I get a seat back, and then what I have to wait until the smart contract. So I entered into this offer, and I'm waiting until the smart contract concludes. When it does, I'm going to get an offer result from my seat. So that's await seat get offer result, right? When everything is said and done, I'll get an offer result. And I want to check what I would like this function to give me as a result of the offer is say hello. So I'm going to test is the offer result hello. So this is the offer result is actually a way you can pass messages back to the user. So you can say you haven't provided enough money. I don't want to talk to you, contract is shut down, or whatever. You can send an object backwards, and somebody can extract it using the offer result. So here I just want to use this very simply. I want to say hello, but I want to do it using invitations. So now, of course, if I save this, my tests are failing because make hello invitation isn't a function. We have to go back and write it. So I'm going to copy this so I get it right. So there's a new function. But now this function doesn't just return the string, it has to go through this whole offer infrastructure. So I'm going to say, whenever somebody calls make hello invitation, it's going to call ZCF, and it will create what's the function? So this slipped my mind. ZCF make invitation. Yeah, so I was right. Okay. So I'm going to ask it to make an invitation. And the invitation is going to has to be handled by an offer handler. So we're gonna give a say hello handler, and there's a name that's useful in debugging that you can give this like a description. So hello handler is our description, and now we have to actually write this, right? So say hello handler. Now An offer handler accepts a seat. When somebody is using the invitation, they are given a seat at the table, and I, inside the offer handler, get access to this seat, right? So this is the seat, and I'm not doing anything. I'm just saying, okay, exit the seat because we're not doing anything in the smart contract. We're going to terminate our work immediately, and I'm going to return hello. And hopefully, if everything has come out right, the test should pass. All right. So this is the flow. Go back into this test contract. In order to interact with a smart contract in the way that is safe to exchange value, we need to use invitations. We get an invitation, and the invitations are also key to access control, right? So as a creator, I can, for example, get an invitation to mint new mullahs, but I'm not going to give this, I'm not allowing anyone else to do that. So this invitation is going to be just for me. But then I can, somebody can trade mullahs for something else, so I can have another facet, which I'm going to return, which we're going to see later, that I can use, that anybody else can use to say, hey, here are some mullah and give me something else in return, right? So this invitation is key to access control and also to offer safety. When I'm a user, when I'm a dApp, I want to use this invitation, redeem the invitation by sending an offer. So I'm going to say, I have this invitation, and I'm going to make an offer using this invitation, and there's going to be a proposal, which is now empty. And then when I do that, I get back a seat. So now I'm sitting at the table, and the smart contract is running, and the offer handler is running, right? Because I've redeemed the invitation. And I'm waiting until whatever's in the smart contract gets run. And this inside the smart contract could be an auction, and it's waiting until 10 people bid, or it's waiting for a week, or it's, this is varied. So you can be inside this await for a while, but once this await resolves, you're going to get back an offer result, and then the offer result tells you what's going on, and then later on we're going to see how to extract things from offer result. So at this point, there's a lot of new concepts. So these tests look very short, but there's a bunch of things we've shown. So does anybody have any questions that you guys want to clarify at this point? Is it making sense, first of all? Is this making any sense? Okay, that's good.
So if I may, the seed is object that is always going to hold the value, and it's persistent.
So it's persistent for the duration. The seat this is a seat that we're given from the outside. Like imagine I'm a user interacting with a smart contract. I get the seat after the invitation is redeemed, and then the seat is valid while the contract is running. And then you can see inside the contract what I actually did is I exited this seat. So what I'm signaling is whatever I wanted to do as a smart contract with this seat, it's done. And at that point, this offer resolves, and the seat extracts the result.
And if you didn't exit the seat, it will just hang?
Yeah, it would just hang.
Is it a way that the smart contract then can keep assets?
So you can actually do that in the next smart contract. That's a good question. You can define seats inside the smart contract, and they can hold assets.
Forever,
So they can. So you'll define them. That's right. You can define them in the start function. Whatever you define here and make here, we're going to make stuff here. Right? That's live because it's any functions that you send out are closures over this whole context. So this thing lives, whatever is here lives while the smart contract instance is running, right? If the instance is killed, then that's different. But while the instance is running, these objects over here are going to be live.
So it's instance of the contract as an application, or when you deploy the contract on the
when you deploy the code, you deploy the code.
Yeah, it's a deployed code, and then the instance
right.
actually interacts.
Exactly, because you can deploy a code for, let's say you want to auction of NFTs. So what some of the example contracts, and we're not going to do that because I think that's really complicated. But if inside my handler here, I can actually create an instance of another smart contract and return back an offer, right? So you say, okay, I want to start an auction for this NFT. You can have an auction contract that lives already, it's deployed, and then you just start a new instance of that just for my NFT that I just hold right now. You dump it into it, and then you allow it to work. So you can do this with covered calls. You can do this with whatever, right? So. And there's a library of smart contracts that's available inside the Agoric SDK, but then you can also do this with your user contracts. Okay. Any other questions? Okay, let's continue. It's all clear and easy. That's great. So Now let's talk about mints and how we can actually, so the first contract is actually a facet contract, right? So the capability that I'd like to give it is, if I'm not too greedy, mint me some mullahs. So the idea is very simple. If I'm asking for less than 1,000 mullahs, it will mint the payment inside the contract and then transfer it to me. So you'll see how value transfer through the seats actually works. And we'll test whether we can deposit this into the purse, excuse me. So how should this work? I'm going to copy a lot of this code, so I don't have to type all of it out. So now, but I'm going to change some things around here. So it's going to be a mint mullah invitation. And I'm going to use this invitation. I'm going to make myself an invitation. And then I'm going to use it over here. But I need to structure this offer differently. So now, for the first time, we're introducing one keyword into the offer. That's want. I want from the smart contract to mint me mullah. So what I'm going to say is, I want 80 mullah. That's what we were asked. So amount math, if anybody remembers, make, and now what brand do I use? What's the brand? So the contract is actually going to be minting the mullahs. So the mint and the issuer and the brand are built inside the smart contract. So what I actually need is to get it out. So I'll have to write another function inside this creator facet that's called getIssuer. And that function is going to move the issuer that's inside smart contract out. Sorry, not move it. It'll give me a reference to the issuer so I can use it to talk about amounts, right? Because when I want to make an amount, I have to say what brand it is. So issuer is getIssuer. I'm going to use the getIssuer function in this way, and then issuer can give me a brand. So I can use getBrand on issuer. And where was it? 80. And I want to mint myself 80 mullah, right? So we're going to have to write these functions, right? These are not for free, obviously. But if we have them, we can then talk about 80 mullah. And I'm going to say here, I want tokens. I'm going to call this tokens 80. Mullah 80. Right? So I'm sending an offer to the facet contract that says, I'm not giving you anything, but please give me 80 of these mullah. So not all smart contracts are as nice as that, but this one is. We're going to write it that way. So it's going to give me the 80 mullah. So again, I have to wait for an offer result. So I'll say const offer result is await e seat get offer result. And I just realized I haven't talked about what e is. E is the way you have to call objects that are remote. So whenever you get something, a good rule of thumb, whenever you get something from Zoe, it actually lives somewhere. It's like a remote sort of version of this object. And when you call functions on it, what actually happens is under the hood, the system has to do a remote call somewhere else. So they get the result of the computation and then send it back. That's why you have to use E and await. So this, instead of you doing it, there is simply just wait a promise locally. But in fact, what it does is it goes and comes back. So sometimes you'll get, if you make a mistake and you don't use this, the test will usually warn you that you can't call this object or it's just going to fail, and then you'll realize that you need to use E. Okay, back to this contract. So first thing we're going to check is that the offer result is here is 80 mullah. So now the contract has to return this, right? If it doesn't return that, the tests are going to fail here. And now we're going to extract the value from the seat. So we say payment is await e seat get payout and get payout of tokens. So I use this keyword. Why do we have these keywords? When you are sending something to the contract or getting out, these can be different things. So at the same, so let's say I want to swap 1,000 USDT and I want to get back 10 Atom and 50 of something else. How do you do that inside an offer? Well, you have different keywords that you can send in and different keywords that go out, and those can refer to different different brands. And also, by the way, you can have multiple keywords that denote the same brand, right? Let's say I buy something and then I get two different sort of mullahs out. I get a mullah for my transaction fees, and I get another mullah. It's for convenience. I can have two different keywords here that say tokens A and tokens B, and you're getting 80 here and 50 here, just for clarity. right? Just because you want to separate these things out. Or you can have completely different things. You can have tokens, then you can have NFTs, and then you can have token A, token B, token C, and all of this comes out in a very nice structured way, so that you can say, give me the corresponds to tokens, give me the payout that corresponds to whatever else, right? So it's very nice and clean. I get all these values out separately. So now we already know how to test payments, right? So hopefully the payment that I got, and we know how to test for amounts. So issuer get amount of payment, because at this point, when I got the payment out, I don't know what it contains. I asked for 80 moolah. The question is, does this thing contain a value that corresponds to 80 moolah or not? So I'm going to test that here, right? Moolah 80. There we go. So once we write everything, if we do it right, this test should start passing. So the first problem we have, mint moolah invitation is not a function. So now that we wrote the test and we see what the interaction is supposed to look like, let's write the contract that does that. So make hello invitation, mint moolah invitation, and this is usable multiple times. What happens if I only wanted to allow use of this one time? Well, instead of that, instead of actually the function, the anonymous function over here, I could just directly mint the invitation. I haven't said this, but each invitation can be used only once. That's a key point, because an invitation is actually a payment, and the payment can also be used once. And we can actually test that. I didn't write that up as a bonus exercise, but one thing we could do in the very first contract that we built, when you create a payment, deposit it in a purse, go ahead and try and deposit it into a purse again. It's going to fail, because the payment is not live anymore. It's been spent. The payment is a value that you can build, and then you can use it. It's not live anymore. You can't clone the value and have multiple uses of it. It's just like a one $10 bill. That's it. So I could make this invitation to be usable only once, but I'm going to make it a closure. I'm going to allow to use this many times. So mint moolah handler. This is again my internal name, right? And I'm going to call it mint moolah for debugging purposes. And mint moolah handler doesn't exist. So this is again an offer handler. So what we're doing is we're writing this out. The standard way is going to grab a seat. And what's the seat? It's the seat of me, the user who's running inside the test and is asking for the moolah, right? So now what is it that I want to verify? This time around, this is the first time we're doing this, we want to examine the offer inside the smart contract. None of the functions have done that. So I want to see what the user wants of me. There are some helper functions inside Zoe that help you work with offers, so you don't have to do all the manual checking yourself. So I'm going to say assert proposal shape. So first takes the seat and then says, hey, what would you like me to verify? So all I'm interested in is that the proposal contains a want, and I want the want to contain tokens, and there should be an amount associated in there, right? So I can say, hey, Zoe, or use this helper function and say, can you go look at the proposal inside the seat and verify that it's got this function, so that I have 15 ifs later inside this contract, right? If this passes, if this fails, this handler dies right away and it returns with an error, right? If it works, then I already know it's got a want object, and the want object has tokens. Next thing I'm interested in is what is the content of the tokens call. So I'm going to say const want, and I'm going to deconstruct seat get proposal. So the proposal, again, it's a simple nested object, and we can work with it as such. So I get the proposal. I already know the proposal contains want, otherwise this would fail. And I also know it contains tokens. So I'm going to say moolah amount, requested moolah amount is want tokens, right? So tokens is a key inside the dictionary, and the value is the request amount. Where does this come from? It comes from right here. This is the test, and I send an offer, and the offer contains what's called a proposal. Proposal contains these keywords. So that's what I can directly see this inside the contract, right? So I'm here, I have the requested moolah amount. And now the task is, if this is less than 1,000, or let's say including 1,000, we'll go ahead and do that. We'll go ahead and mint it. If it's more, we're going to return an error message, say you're asking too much, right? So how do I do this? I can use amount math, and I can actually use assert here. I'm asserting inside the contract that amount math is GTE is greater than or equal, and I have to import amount math is greater than or equal. So what has to be greater than or equal? So amount math make, and now again, we've got this problem of brands, right? I have to make an amount of a certain brand. We haven't talked about how we're going to create this money at all yet. So what I need to do here is create a mint. So for convenience purposes, or just because Zoe contract facet gives you a different kind of mint that's synchronous that you can use inside the contract. So I CCF make ZCF mint, and it's going to be a mint for Mula. And then I can get a issuer and a brand by asking the mint get issuer record. So when I was in the test, I used make issuer kit, and it gave me the mint, issuer, and a brand as one object. It's different inside the smart contract, but not that much harder. Okay, it's just different functions, and they gave us a little bit different functionality. But now we have an issuer and a brand, so we're in business. So I can go here and say, this is the brand I'm talking about, and this is the value I'm talking about. So 1001 and more, we're going to say you're too greedy. If it's less than that, we're going to be good. So if requested, let's assert that 1001 is greater than or equal to, actually 1000 more, greater than or equal to the requested Mula amount. So we're going to accept 1000. If we put 1001 here, this assert's going to fail. And you'll say, you are too greedy. You're asking too much. So if we pass the assert, that means it's all good. The requested amount makes sense. So let's actually go ahead and use the mint to now create this value. So I'm going to say mint gains, and this is again a convenience function. So we're going to mint into the seat whatever the user wants. So what this does, actually, let's go back. Let's see, like when I'm developing this and I'm looking at this, I like to use the Agoric. No, not the team. Huh. Interesting. CCF mint gains. Zoe contract facet. Okay, that's better. So it's usually very easy to go and find whatever you need. The docs are evolving quickly, and the system's evolving pretty fast, but the docs tend to be helpful. So I'm going to mint gains, and I have to say what are the gains and which seat. So actually I have this the wrong way around. Right? I would be warned about this inside the test, but let's fix it right away. So what I'm saying is mint gains using my mint over here straight into this seat. So now inside the contract I'm saying this seat is going to get this value. And the want is just a dictionary, remember? And this dictionary contains tokens and the amount I want to mint. And the mint understands this, and it will deposit into the seat tokens with under the key tokens this amount. And then I'm going to say seat exit, and I'm going to return. Here is requested Mula amount dot value Mula. Hopefully I got this right. So let's see if my tests pass. Tests failed. Mint get issuer record is not a function. So what am I doing wrong over here? Get issuer record is here. And am I using the wrong function? ZCF mint. Get issuer. Yes, but so that's a good point, using the get issuer. I haven't written that function yet, but this error is already inside the contract. It's not inside the test. It's telling me if you go back here, mint get issuer record is not a function, and I'm using that over here. So I'm doing something wrong with this mint, and I think maybe this is an awaitable object. So make ZCF mint returns a promise. Here we go, my bad. Await, and now this should work. Get issuer record, right? So let's see what happens inside here. And I get a failure. Get issuer is not a function. Now we get to your issue, right? Because I didn't define this other function that I promised to define. So let's say get issuer. And now that I have the mint and amount and the issuer created, it's really easy now, right? So I'm just going to say send the issuer out. And that's it. So now let's see what we get. Here is 80 Mula. Ah, tests are failing because instead of an exclamation mark, I asked for a period. Need to fix that typo. Here is 80 Mula, and we're going to be happy about 80 Mula. There we go. So value 80 and a promise. So Here again, my test is failing, and it's failing at this line over here. And the reason is I forgot on a wait. So it says, oh, I'm seeing a promise, but you were supposed to see a value, right? So let me fix that. Tests are passing, right? So again, I come back to this idea. When you're developing your smart contract, do yourself a favor and use the Eva testing framework, because it really gives you a super fast feedback cycle, and you can correct your errors very quickly. So now we're at deep equal, okay? And what we're going to do now is test whether our other functionality works. When we're too greedy, we're actually not getting anything out. So if I just copy this test over here that we wrote, and I'm going to say 5,000 instead of 80, so what should happen? How do I change this test for this to pass? Given the contract that we wrote, what should I change here to make sure that the test passes? Like, here's the contract that we wrote, right? Here's the handler. So that's what's running when I'm sending the offering. So there's two things that need to change for this to run. The return string is different, yes. And I think we said the offer result is you are too greedy. So that already should signal to us that we're doing, oh, there's a full stop here though. What's with me and the exclamation marks? Okay, so you're too greedy. So if I write that, I fix that. Rejected promise. Return by test. All right, yes. So here's the thing. We can do two different things. One is use an assert inside the contract, which I use now, and it actually fails the contract, so it throws an exception inside the test. Let me just change this really quickly and do it like that. If the condition is not satisfied, I'm going to say seat exit, just like we did before, and return you are too greedy. Dot. So what happens now? Test failed. Why has it failed? There's a difference in the very last. So now the string test passes and actually got my result back. I'm going to come back to this difference later, but the assert will actually fail in a way that an exception is thrown to, instead of getting the offer result, you're going to get an exception thrown in your process. But if I use this if here, I'm just exiting regularly. What I'm saying is I'm not minting you anything. I'm just exiting your seat. I'm going to return the you are too greedy, which is what's running now. But why my test is failing now is because there is no payment of 5,000 in there, right? So what actually happens to fix this test, what I have to do is say amount math make empty and use the issuerkit brand, right? So what I'm saying is compare the payment that I got with a zero value, and I can verify that I have not been giving anything by contract, right? I asked for too much, I got the result you're asking for too much, and also the payment that I can still extract a payment, but it doesn't contain anything. So let's look at this other way. To make the test pass, by the way, if I go back and do this, I can actually, and do the assert, I can still make the test pass. And the way I do it, there's probably a better way, but the way I do it is this. I say try, and here I'll fail the test. If I get to here, then the test is failing. The test should fail here because an exception should be thrown. And if this is the last test, obviously this works better. And here I'll say tpass. Okay, right, I'm going to comment this stuff out. So now that the assert is in there, my test passes. Why does it pass? Because instead of when this line gets executed and an exception is thrown, this never gets executed, the fail is never seen. Instead, I pass to this exception handler and we'll say the test is passing. So that's one way you can test like assertions thrown inside a contract. So there are two ways you can sort of like kick a user out. One is, or you can terminate the contract. One is you just assert something and that throws a hard exception that goes and that's propagated across the remote boundary all the way to the test. Or you just do a standard if, you exit the seat yourself and extract it. And also, by the way, I can fail the seat, right? I can say to indicate that something's wrong, I can write seat fail here. That's another way to end this. That communicates that something is wrong with the transaction, right? But this is more semantics. This is what do I want to communicate to the user on the other side? Has this failed, or has it been successful but in a different way? All right. So that's us at this contract. So here I want to go back and say we covered we first touched on the Zoe functionality, right? So in contract 0, this was no contract, just understanding issuers, amounts, payments, purses, this sort of infrastructure to define tokens. So the second contract, that's where I want, or contract 1, hacker counting, second contract 1. What I wanted to show is how does this invitation lifecycle work? So contract exposes objects, which in some cases can extend invitations. I, as the user or as a dApp, I go to the contract, say, hey, can you, if I have access to some invitation infrastructure, I say, give me an invitation. When I have that, I can then talk to the contract. So this means that there is a contract deployed, there's an instance, and I can talk to it. It's already guaranteed because I'm getting an invitation. Otherwise, who's giving me this invitation? So when I have the invitation, I'm allowed to use it to send an offer. The offer can contain keywords, something I want, something I'm giving. And then the contract gets to see this, examine the offer, decide whether it likes it or not, and then send it back to you. We haven't shown yet how Zoe protects the user. We haven't done any of that. And by the way, if you hear, just want to point out what offer safety means, or how it works now. If you ask for 80 mula and the contract instead of 80 mints you 40, Zoe will allow this to pass through. The reason is you haven't sent anything to the contract, so there's nothing of yours to protect. So I asked for 80, I'm getting back 40, but since I didn't give anything in return, there's nothing violated in the sense of, hey, I wanted to sell you this for price A, but you gave me half and kept it. Right? So Zoe won't stop this transaction. If I build a new amount here, instead of this, the test should still pass if I do tokens, amount, math, make, and I'm going to use the brand and say 20. So actually the test will fail on testing the amount, right? But the offer went through. I sent an offer to the contract. I asked for 80. The contract only minted me 20. The offer result was successful. Here you go. But the payment, when I checked the payment didn't contain 80. It only contained 20. And again, I'm saying Zoe is not going to stop this because I haven't given anything to the contract. So there's no protection that I need here. Right? I can be unhappy. And if I did something offline, off-chain, you said I'm going to give you 80, and then I went and did something off-chain, that's a problem. But on-chain, I didn't give anything into the contract, so I'm not losing anything. That's why Zoe is not protecting me. But in the next smart contract, we'll see how Zoe works. So I think we're doing really well on time. I want to do a short break because I think it's really. So do you guys want to come? Shall we go again in 10 minutes? All right. So let's continue. I want to go just for a second back to this very first contract called contract 0 because I was asked about invitations. So invitations can only be used once, and under the hood, invitations are actually payments. And we talked about payments right here in one of these first tests. And I didn't make the point, which I want to make now, that the payment can only be used once. So when the payment is minted, it's live in the system. So what happens is, once this payment is minted, I can ask T and verify if it's true that the issuer get is live of the payment is true. Right? So this part should pass. And actually, I think it's an awaitable. It's promise again. So forgot await. So the execution passes through. So once I mint the payment, it's live. Once it gets deposited, what actually happens is this turns to false. All right. So if I deposit this out, the test should pass now because I minted the payment. It was live. Then I deposited it in a purse, and it's not live anymore. So the issuer can actually, so I said it was a useful object. The issuer for that connected to the mint can tell me if a payment is actually already spent or not, if it's live. If it's live, it's not spent yet. So what happens if I try to deposit this again into a purse? I deposited it, the payment's not live, and now my tests fail. And what I get back was this alleged mula payment was not a live payment. So it can be a used up payment or a payment for a different brand, or it might not be a payment at all, right? So So I can't deposit this thing twice. The way I can make this test pass again is I'm going to use a try-fail. I'm going to use a try-fail thing here. Now my test pass, right? So I can't deposit this payment twice. An invitation is also a payment. So once you use up the invitation, that's it. And this also means you can transfer these invitations, right? Let's say I interacted with a protocol that's like an option call. So it gives me the right to buy something at some price at a later date. And I paid a premium for it. And I got the contract as a result. The offer result is another invitation. That's possible. So I can then, what do I do with this invitation? I can use it and interact with it, but I can also sell it. So an invitation is actually a payment. So I can sell the invitation to somebody else, and that person can use the invitation because it's a value. The invitation is value. Like it's your ability to talk to the smart contract, and you might have gotten this invitation at cost, so you can then trade it with somebody. It's an invitation from you, then they can use the option. Right? So just wanted to make sure we're all clear here. So,
Can you limit that?
sorry.
Can you limit that? Let's say you don't want your invitation to be faithful. Like, I only want this person to use this invitation. It's not for anyone else.
That's a good question. I don't know. I don't know where you can. So first of all, if I'm the user, then yeah, if I don't share the invitation object with them, that's it. But if I'm the contract, you'd somehow have to verify the identity of the person, and I don't know if that's currently possible. It's a great question. So let's move to this next smart contract here. So initially we talked about just this ERTP infrastructure. Now we talked about Zoe invitations, seats, offers, etc. But we only live inside one smart contract. But this selling point of blockchain is like this stuff is composable. I can move objects between and connect contracts together. So how does that work if you want to accept some sort of currency? So in this third contract, so now we went through contract number 1, and if we go through contract number 2, the idea here is, or what I want to present is how to connect two contracts together using by connecting their issuers. So that one of them knows about the currency or token or the asset type that's emitted by another contract, and I can use this. I can connect them. And what the contract's going to do is it's going to allow NFTs in exchange for moolah. So what I'm going to say is I'm going to inside my tests I'm going to mint moolahs, and then I'm going to use those to go and buy an NFT, right? So an NFT is going to be minted for me, and I'm going to send the moolahs into the contract. So contract is empty again, and it's actually much simpler than the other contract. Here, what we're interested in is, here's what we want to do. We'll create a moolah issuer kit. So we ourselves the right to mint these tokens. And then we want to instantiate a contract that we're going to tell about what and then that contract is going to know about moolah and can accept it and check whether it's actually moolah, and then issue you NFTs in exchange. So let's start by moolah kit, create issuer kit, moolah, and the asset kind is going to be NAT. So these are fungible. Again, I'm going to get moolah issuer brand and mint, and that's my moolah kit. So I'm naming these more carefully now because I'll have multiple issuers. I'm going to instantiate contract number 2 into a VAT just like I did with contract 1. I'm going to go ahead and copy that code because I don't want to write it out again. Oh, no, that's okay. And I'm going to be in the world of contract number 2. Make fake VAT. Admin have to import all these things just like before. So import Zoe, import the bundle, and import my eventual send object, which allows me to communicate. Call this NFT installation. I'm to gain here in source contract into the vat we've created for testing. So I have a, just like before, vat and create it, and we create an instance. The key thing here, start instance, the to tell about the terms we wanted to accept and the issue to know. So there are two objects in here. Why am I not getting actually help in start instance? Or okay, I was getting over there. Huh. So interesting. So code intelligence tells me what the object is here, but not over here. Okay. So it accepts actually the function accepts two other arguments, and one is, I'm going to use code intelligence over here. That's the wrong test contract. Apologies. Here we go. I'm going to use this object to show you. It says I'm accepting an installation, so we are sending the installation. That's the code that's been deployed, and then it accepts a issuer keyword record and terms. So what's an issuer keyword record? So if you recall in offers, we are using these keywords, and with an issuer keyword record, we can tell the contract what issuers are going to be used in connection with what keywords. So now I'm going to say tokens are going to be moolah. Right? Anytime an offer comes in with tokens, it's supposed to have this asset in it. If this has to fail. Right? You can't use your Canadian dollars in place of the US dollars. And it's easier for me to use terms since I pick up this issuer. So I'm also going to say that I'm going to repeat the same thing. I'm going to send the issuer into the contract into the terms. So now, so we haven't written the, but we have. And the instance already knows about the moolahs that we just created. Now here we're creating them inside the test, but they could be created in another contract somewhere else, right? And get issuer function that we wrote for the contract, so I can deploy the first contract. And I have the moolahs that are in the original contract. I got the issuer in my hand, and I can tell another contract, hey, you start up, and you're going to accept the moolah that I'm just providing you. This is the issuer that's going to issue the moolahs, right? And everything's going to be run through here. So this is what we're doing here, but we've just created the moolah kit ourselves, right? Because this is a test. This is a test environment. And now here's what we'd like. We're going to say, we're going to create a public facet here. Instead of a creator facet, I'm going to create a public facet just to show you the other side, how this can be done for public use. And const mint NFT invitation is going to be part of the public facet, and also get issuer. And I'm going to call this get NFT issuer. So imagine we have a first contract, which is a faucet which mints us moolahs. Then we were telling another contract, you're going to accept moolahs and you're going to mint NFTs for me. But the NFTs are again, they're going to be there's going to be a mint, a brand, and an issuer. And I need to have access to the issuer to be able to verify if this is the right kind of NFT. So I'm going to ask to be also able to update the issuer. And by the way, NFTs I want to this issuer. This is how you recognize whether the NFTs are the right kind, right? So and what we're going to do now, const invitation, and I'm going to call the mint NFT invitation. And then I want to get a seat. I'll wait Zoe offer, and I'm telling Zoe, hey, I have an invitation here to mint. And what goes in here? Anybody remember inside the offer function? What is this? This is the, yes, exactly. This is a want and give. This is a proposal. Yeah. So I'm sending a proposal, and I'm saying I want. And let's say I want this to mint for me, and NFT of a certain type. So to be able to describe, to actually grab that issuer here, right? NFT issuer is get NFT issuer. And now I can describe what I want. Mount math make, I'm going to use NFT issuer get brand. So give me the brand. And I'm going to say harden, remembering my lesson here, and it's going to be awesomes1. So that's my unique code, my unique identifier for my NFT. And the second thing that we haven't used before is I'm going to give something in return. The contract's going to ask me for something. So I'm going to give, I actually forgot the, I need to use the keywords. Remember I said we need to use keywords to describe the different parts of the want, different parts of the gift, so I forgot that here, right? So I want to give tokens, and this has to be the keyword that is here connected to the issuer. So this is the link, right? When I send the tokens, I'm going to send something here. I'm going to send an amount. That amount has to correspond to what I told the contract earlier to accept. So I can't swap this and make my fake money and put it in here. Contract knows what it wants. So amount math make, and the offer is a description. The offer contains value whatsoever of any type. It's a description. It says, I am proposing for you to give me this in return. For you, I want this, and I'm going to give you this. But there's no values here. There are no payments. These are all amounts. Amounts are just descriptions. So I'm going to make of the, now this is the Mula brand that I actually issued in my test, but could come from anywhere else. I'm going to send you 100N. This is my proposal. Now, if I send it like this, the contract's not really going to be happy. Why is that? Because, one second, might have want awesomes, and why is it not like this? Pardon? Oh, yeah, there we go. So let me actually format this proposal a little bit better. Make it easier to follow and write. So, const proposal. And I want to put this on new lines. Just to make this a little bit clearer, I have a give, and the give is only of, I'm giving one kind of thing, and that's it, right? So what I'm saying is, hey, here's my proposal. I want this, and I'm going to give you these 100 mulas for it. But if I send it like that, okay, too many closing errors. If I send it like that, that won't work because there's no payment. The contracts actually want to keep the payment, right? And it's not sending any payment. So we have to actually make a payment of 100 mula. And how do we do that? We mint payment make mula brand 100N. So I'm saying make me 100 mula, and I have access to the mint. Ain't I a lucky guy? So I'm going to just mint this money for myself. Now mula 100, mula payment 100. And now I can send this here, and I say, you know, I'm sending you this offer, this proposal, and please, for tokens, use this payment that I have. So this is inside a test. If this was on a chain, I'd have a purse with mulas, and I'd say, earlier we deposited into a purse. I'd say withdraw 100 from the purse. This gives me a payment. We only created payment, but I can actually, if I mint payments, put them in a purse, I can withdraw something, and that's something's going to be another payment. So let's say I withdrew this from my purse, and I'm attaching it to this proposal. That's key, right? So I'm sending the proposal, but I'm also sending the value along with the offer, right? Okay, then what happens? What I'm expecting is an offer result. Again, wait seat, get offer result. And the offer result better be, here is your NFT. Offer result. I'm just going to swap this because the actual is this and expected is over here. Okay, and then if that works, what I want to do is extract the NFT out. I want my payment. So const my NFT payment is going to be seed again, get payout. And payout of what? I'm expecting this to be under the key awesomes. That was part of my offer. And so I'm awesomes. And then I can verify where is the amount that I asked for? Okay, so I'm just going to factor this amount out so I can have it my NFT amount. Right, here we go. So, and I'm going to check whether the NFT that I got is actually this, right? So T deep equal, and which issuer can verify this NFT for me? Well, the NFT issuer that I got over here. So I'm going to say NFT issuer get amount of NFT payment. I'm going to await this here. And what I also want to do is check it against the amount that I initially specified, right? So when we finish writing this contract, this test should check out. So let's go back and write this contract. So here, for the first time, we're going to extract terms. So I'm going to say const, I'm going to say terms is ZCF get terms. The terms will just give me the object that I passed in over here. I passed in terms. So this is the issuer keyword record, and these are the terms. I use the same keyword. I can't decide if it's more confusing to use different keywords to show you that it doesn't have to be the same, but it's actually the same issuer, or use the same keywords, but those are two different things. So one is the issuer keyword record, and these are issuers that are recognized as sort of like valid forms of payment by the contract. The second one is the terms. I can add anything else here. I can say deadline 7 days, 7 something times inside days and seconds. Right? I can add anything else I want here. I can extract it inside the start function. So this is a way to pass actually parameters into the contract, and they're called terms. Because frequently there'll be actually contractual terms. So if I'm starting an auction contract, the terms is a great place to say this auction is going to run for 2 days, because it can be as a parameter inside the contract, and I can set this parameter right here inside the terms. So anybody else can see that, how this runs. So let's go back into this contract. I'm going to extract the terms. Inside the terms is a keyword called tokens, and I know there's a Moolah issuer there because that's where I placed it. So what do I need to do here? So here I've actually created a public facet. And the name public facet is interesting because there's actually a function that can get the public facet. So there's a get public facet function which you can call on any installation that you have access to. And that's where this sort of object capabilities, access control comes from. So if you define something in public facet implicitly, anybody who sees the installation can get a handle of that public facet. Any functions in here, anybody can call. Right? Other names don't get exported automatically. This name does. So public facet. What I mean, how did I call this invitation? Mint NFT invitation, and I need a get NFT issuer. So let me just copy these functions here, these names here. And again, it's very clear here. I'll need to make the issuer, so I'll just do that right away. Const NFT mint is going to be ZCF make ZCF mint, and it's going to be for awesomes. And then I'm going to say brand NFT brand issuer NFT issuer is NFT mint get issuer record. Okay, so this is boilerplate. We've done this before. I'm creating the NFT brand that I'm going to use to issue those NFTs. And here I picked out from the terms the Moolah issuer so I can use it in talking about the payments. And this function, again, the get NFT issuer, that just exposes the issuer to everybody. There's no danger in exposing the issuer. The issuer is an object that can't really create any value, but it can verify payments, and it can tell you what the brand corresponding to the issuer is. So NFT issuer will just return this. And get mint invitation is going to return. Anytime I call this, it's going to say ZCF make invitation. And for my mint NFT handler, and I'm going to say mint NFTs. All right. So the objective for us is now to write a mint NFT handler that accepts a seat and does this whole job for us. So it should look at the offer, examine whether what's being offered is good enough, and I think the condition that what we're saying is we want to accept it doesn't say here, but I think what we should do is like set a minimum price on the NFT of 100. If you give us 100 and more, we're fine. If you give us less than 100, no NFT for you. So what we're going to do here is, again, we're going to use a helper, assert proposal shape. The seed is sending a proposal, and it should look like give tokens, and that there should be an amount here, and it should want awesomes. If it wants something else, can't help you, right? This contract can mint awesomes collection, not anything else. So if this passes, then we know there is a give and a want that the seed is proposing. Get proposal. And now what do we want to do here? So we want to actually check, I'm going to use assert again, that we are being offered at least 100 moolah. So I'm going to make my test amount, const moolah 100, amount math, you've seen this 100 times, make, and I have the issuer here, moolah issuer, which will give me the brand, and I'm going to say 100n. So assert amount math is greater than or equal the user give tokens, then moolah 100. If not, if the assert fails, we want to fail with the message not offering enough moolah. At least 100 moolah required. Right. So here's when we check that we're getting at least 100 moolah for our contract. Okay, then let's say this has happened, right? We test. Now we're going to want to mint whatever the user wants. But here's how we're going to do this. We're going to create CCF seat. We're going to, for the first time, this is the first time I'm introducing this, we're going to create a seat that's inside the contract. Somebody here asked about like how you can use multiple seats. So we can actually create seats inside the contract. It's a special type of seat called a ZCF seat. And make empty seat kit. I think that's what the function is called. I'm not getting any code intelligence help. So let me quickly make empty seat kit. Yes. Make empty seat kit. So this should work. ZCF seat. And what I'm going to do is now I want to start using Zoe for actual offer safety. Here is where Zoe should actually come in and protect the users. And for that, we need to set this up a certain way. So I'm going to mint gains. So I have this, and I will mint gains whatever the user wants, but I'm not minting it into the user seat. I'm minting it into the seat that I just built into the NFT seat. So now I minted the NFT into my internal contract. And now what I want to define this trade. So user sent me a proposal. So I'm going to say, and I'm going to want to honor that proposal. So the mint now has the NFT that I want to get to the user, and the user has hopefully sent me a payment of 100 moolah, right? So I want to say NFT mint increment by. I'm doing this in detail. There's a swap function that can do it, but I want to do this in detail just so we walk through this. And sorry, not NFT mint, NFT seat increment by user seat. This is now the user seat decrement by give tokens. And I don't remember if decrement by is actually no. So actually, just give. So what I'm saying now, okay, Zoe, pay attention. What I would like to happen as a result of the smart contract is for the user seat, which now says, I'm offering this 100 moolah. Take those 100 moolah, take that amount, and move it to the NFT seat. So I'm saying whatever the user wants to give, remove it from the user, add it to the NFT seat, and then seat, user seat, increment by NFT seat, decrement by want. And I'm saying the NFT already has that NFT minted in it. Sorry, want awesomes, not tokens. Yeah, apologies, I made a mistake here. So what the user wants is awesomes, right? So I want to mint those gains into the seat, and probably without the keyword again. So it's going to mint awesomes into the NFT seat. And now I'm saying, okay, remove the moolah tokens from the user, give them to the NFT seed. Take the NFT from the NFT seed and give it to the user. And this is now what's called like an get stage allocation, right? So I'm saying this is the change that's going to happen. And please, Zoe, reallocate. And then seed exit. Return, here is your NFT. This is a whole lot of stuff. I'll go through this again. Here is your NFT. Full stop. So let's see what happens now. One uncaught exception. And we again need to move the test. This is a wrinkle. We need to move the test to be the very first import over here. Otherwise, the tests keep failing. Where am I? Mine contract. Yes, so this is can find. Oh, fake vat admin. Yes, it's the JS thing. Why does code intel not fix that? Thank you. Right, so one test failed. The amount brand, Awesome's brand, did not have asset kind of type NAT. Rejected promise written by test. Reason. So why is that a problem? Where are we getting this error? Make get issuer. Oh, wait a minute. Did I say here? No, I did not. So the default asset kind is NAT, but we need to tell this person we want to use a set because these are the NFTs. So asset kind set. Okay. Asset kind needs to be defined. So why am I not getting any IntelliSense here? Contract. So asset kind, where do we define? I need the asset kind import. And is the asset kind import over here? Yes, from ERTP. Okay. So go back to our contract here. And, oh, there we go. I already have it here. So let's keep working. So reallocating must be done over 2 more seats. Yes, so the thing that has to reallocate accepts. So I'm asking Zoe to reallocate, but I have to tell it which seats to reallocate. So again, my tests warned me. 2 tests passed. So my test now passes. What this means is, let me go back into the test contract and actually violate this just so you guys see what's going on. So what's happening is, I as user send a proposal. I defined a currency somewhere, a fungible token somewhere. I explained to the contract the fungible token that it's supposed to accept these mullahs. Then I minted myself some mullahs. I sent a proposal that contains a want and a give. I got an invitation. I sent out the offer with the payment, and I'm getting my NFT back, right? And the NFT actually is correctly defined as Awesome's one. So if I actually change this back, this should start working. So now we have a whole working contract. So what happens? This is the point where Zoe comes into play. Imagine I'm writing this smart contract and I introduce a bug. The bug is that I grab the tokens the user wants to give me, but I don't mint the NFT and don't give the user anything. So all I have to do is comment this line out, right? And I'll do a reallocate. And then I'm asking a seed to exit. And by the way, the ZCF seed, it survives multiple runs of the mint NFT handler, right? So the ZCF seed is built here. And if I mint multiple times, the reallocation keeps allocating the money into the ZCF seed. Providing this allocation to the ZCF seed, and it's moving those every time an NFT is minted into the NFT seed that I have inside the contract. It's reallocated to whoever is talking to me, but their funds are moved into the NFT seed. So this is like a seed that's keeping a track of how much money I got into here. They can later extract it. That's actually a bonus exercise that you guys can ask about later if you're interested in the reward. But now, so what I'm doing here is I'm saying, the contract has a bug or it's malicious, and me as the contract developer, I'm not going to give the user the NFT, so I'm not going to increment it. And I got a failure here. This is what Dean's talk was about, right? Offer safety was violated by the proposed allocation. Tokens brand, value 0, etc. So it shows you what happened, what's actually happened, and what the proposal was. And the gist of this is, hey, the user said it's going to give you 100 mullahs, and it wants this NFT back, and you want to keep the 100 mullahs, and you're not giving the user anything else. So the moment you call this, the reallocation function is actually moving stuff around and resolving this proposal, so it's going to say, nope, offer safety was validated. And this is like a core piece of, it looks easy, it's like it's a line here in the test, but this is one of the core value propositions of Agoric. Like this doesn't really exist in other chains. So the test is gonna run just fine if I actually provide the NFT, but I just rerun but if I don't, the test fails. Right? And here's the thing, like this fails regardless of if I was a user. So inside this test, I'm actually talking to this contract as a user. This is a public facet. I can actually go get that on the chain and talk to this contract. And what happens is Zoe will stop this for me regardless of whether I've audited this contract even. Anybody says ever audited, it doesn't matter. It's just it's good.
Maybe I just missed it from the beginning, but the check is based on the property naming give and want. So is it some convention I should name this?
Yes.
Way?
Yes, give and want and deadline is another reserved keyword over here. So for example, if this isn't like a proposal for an option, if you say, I will sell you this if you for 100 if you buy it within 2 days. So you can use the keyword deadline that says 2 days, and then after the deadline, the offers automatically stop.
But then the inner properties of each one give are totally up to me how I name it.
Yes. You need to use uppercase letters here, but you need to use them. Yeah. But for tokens, you have to use this right brand, which you said here. You said, okay, for tokens, we're going to have to use using mulas, right? But then you can define these keywords any way you want, right? So this is the first contract where we're actually sort of bringing in an issuer from the outside and asking a smart contract to accept money that's represented by this issuer, right? So this is the beginning. This is the first time where we can connect sort of contracts together. I want to buy an NFT for the wrong currency. So let's say I'll do this entire thing. Let's say I want to replicate this test, but now I'm going to make myself another kit. Of asset kind NAT. So I made a new fungible token, right? And now let's say I, as the user, I want to swap in like a different amount here. Test failed. The brand that the amount that I'm trying to send here isn't really the brand that I said is going to be associated with the word token. So which means I'm trying to slip a different currency into the offer, but the contract says no, that's not going to work. Right? So you can't buy these. So the contract knows about which currency it wants to accept, which tokens it wants to accept. Right, it's 1527. I didn't really get to deploying these, and I didn't expect to be honest. Like we're lucky we got through both all of the contracts. But there's other code in this repo that I can very quickly run now for those that are interested in a few minutes. And VM use 16, which deploys both of those contracts to a test chain that I'm going to start here. And I like to run it this way, that I have 3 windows. So I run the chain over here, and then I run the use 16. I deploy the wallet. So and the contracts. I can't go into detail anymore about how this is done. What I'm going to do is I'm going to deploy both contracts to the chain, start up the wallet, so you can see what the wallet looks like, and then start the React UI dApp, that example dApp that we wrote that allows me to mint the Moola. React UI. So if you wait for a few seconds, it's going to say I'm deploying the wallet, and the wallet's going to be deployed later. And then I'm going to say Agoric open. This will open the wallet the moment everything starts up. So this is called essentially local chain deployment. It's actually also possible now to connect to the Agoric testnet. So you can use the very same Agoric start, but you have to give it different arguments. It's going to go and connect to the current testnet. But then we'd have to go to Discord and say, hey, Faucet, give me some run that's actually accepted for an issuer that's accepted on the testnet for fees. And then there's the whole shenanigans. We don't really have time for that. So I'm just going to start one process that starts a fake chain locally, and it's only on my laptop, right? It's still starting up. It's going to show a few more zeros, a few more O's.
Do you already have to pay for invitation? Like I send an invitation, is it something that you need to transport?
So you could write this functionality, right? I'll give out invitations for money. But right now, if you write a smart contract and you definitely need tokens to deploy the contract. I don't think I'm not sure if you need sort of currency to interact with the contract. Not 100% sure. And this is going to change, right? So they're going to go mainnet 1 at the end of the summer, and then mainnet is going to come. So while it's deployed, this is what the Agoric wallet looks like. So it's got a bunch of money in it. It's not exactly real. So don't rush to spend the USDC. But something to work with. I'm going to run Agoric deploy. This is all, by the way, in the GitHub repo. If you want to do this, all these commands are in the GitHub repo. You can just copyright them. And this is going to deploy both of those contracts that we just wrote. And it's not deploying the contracts I wrote now. It's deploying the contract solutions that were already in the repo. Just, because I changed things around. I didn't write it exactly. It's the way it's there. But to work with the dApp, I need this to work, just like the contract solution. And what happens now, there was a question about this during break. When you deploy the script, when you deploy the contract, the script itself, this deploy script is a JavaScript script, and it grabs the IDs of where the contract is on the chain. It stores them in a JavaScript file. It's like a .js file. And that's picked up by the dApp, by the application. So it knows which contract it's talking to, right? Because it's already deployed here. So there's contract number 1. Contract number 2 is deployed in a second. So it's running, see, and it's Mula Minter Constance contract mark. Both contracts are deployed, and I'm going to start so I move to the React UI, and I'm going to go to yarn start, right? So we built a very simple application. It's going to start up here. And now it's telling me, waiting for Agoric interface to be activated. So first thing that happens is you have to approve this in your wallet. So, and that's also how offers work in practice. So we've only looked at this in tests, but I want to show this one run through to show what this happens, like what works if you deploy to chain. So I say accept, and now this app can actually talk to the chain, right? So this is initializing, and in a bit it'll show me that I'm allowed to mint. I'm allowed to mint in the Mula mint. So this actually talks to the contract number 1, and I'm going to say mint me 60 Mula, get me some Mula. And again, another interesting thing: offers get shown inside the wallet. Right, so we've added a lot of helpful sort of console messages. So even if this interface told me I'm minting you 600, it doesn't really matter because the offer is shown to me. The wallet parses the offer and shows me what the offer says, not what the UI told me. So actually, I as the user, because I have access to this wallet, I don't need to even trust what the dApp is showing me, because I can examine this inside my wallet. When the offer comes through, I'm saying add this offer to your queue, and this wallet picks up the offer that I sent from the dApp. And then I can say, yeah, I approve this offer as a user. I like this. It says want, so it's parsing the want keyword. And this is all stuff that Mula has a certain name here. I won't go into detail, but when I approve, these new purses, and again, these are the wallet, you already know a concept of purses. Purses hold only one type of currency. So I've been given 4 purses in the beginning, but my dApp has said, hey, could you, as the wallet, add 2 more purses for these issuers? Right? And that's the Mula issuer and the awesome NFT issuer. So they're both added to the wallet now because I suggested it from the dApp, they're added. And now the offer is already talking about this Mula purse, and I accepted the offer, so 60 Mula has been deposited to my purse inside my wallet, and I can go and work with it. So this is it for this workshop. Thank you for lasting 2 hours. Good job. I didn't expect everybody to come back after the break, honestly. So I hope this has given you sort of like a starting place. Like this is the very, very beginning of working with Agoric, but I'm hoping you have the absolute baseline that's necessary to even like begin to read the documentation and understand like what's going on. So thanks very much for coming.